Welcome back. As you know, I am Eli, the computer guy, here for the Daily Blog, where I shake my brain nips every day in order to get some of that dirty YouTube money to be able to afford to teach you folks classes in the real world. Silicon Dojo, silicondojo.com, in-person hands-on technology education classes that empower you to do whatever the hell you want to do. We're having a class coming up on AI and SQL next week. We're having a class on AI web scraping on November 19th. If you're interested, take a look at silicondojo.com. And I think this is an interesting story today, talking about Google's TPUs. Remember TPUs? They're called tensor processing units. They came out about a decade ago, and we were told these are the future of artificial intelligence. Remember 10 years ago when we were talking about AI? You know, because AI has been around a wee bit longer than ChatGPT. Anyways, basically there's things called tensor processing units. When you're dealing with artificial intelligence, when you're dealing with neural networks, there's these things called tensors. Tensors are three-dimensional arrays. Basically, an array is essentially a variable that can store multiple values. So you can have a two-dimensional array then is a variable that stores arrays. So that's what becomes a two-dimensional array. And the three-dimensional array is a variable that stores arrays, which then stores arrays, and that gets you these things called tensors. And so Google came out with these things called tensor processing units, again, about 10 years ago. I remember going to CES. And they had like this AI phone. They had like this AI phone thing that was running on TPUs, or at least had TPUs installed. And so we all thought that tensor processing units were going to be the future. And then, people basically stopped talking about them because like NVIDIA became the thing and everybody kept focusing on GPUs, and TPUs is one of those things that kind of just seem to fall to the wayside. Now, one of the important things I want you to be thinking about with the artificial intelligence world right now is when you hear about Sam Altman wanting to spend $4 trillion on CapEx expenses for artificial intelligence, when you hear about Mark Zuckerberg wanting to build a data center literally the size of Manhattan, Jesus Christ, on AI. When you hear about all these big projects out there, one of the things that would be easy to be mistaken about is to think that this technology is mature. So when we talk about mature technology, think about like web server technology, Apache, Nginx, IIS, if it still exists, right? You go to a website, right? You have a web browser, you go to a website, and everything happens, right? You got CSS and HTML and JavaScript and all that kind of stuff, right? That is a mature technology. We all know how it works. We all know how to use it. Companies have learned to play nicely together. If you remember the 90s, right? There used to be specific tags for specific web browsers. Some web browsers would respond to some HTML tags, and other web browsers would respond to different HTML tags. That's how it used to be, and that was when the web was immature. Everybody knew the value, or had an idea of what the value of the web would be. Everybody's building out this technology. There's a lot of competing stuff going on, and basically it takes 20 years, probably till about 2015, really till HTML5 became standardized, before everybody just kind of agrees on how this crap is built out, right? If you look at GoDaddy's server farm, it's going to look a whole lot like HostGator's server farm, which is going to look a whole lot like, cheapdomains.com's, server farm, right? They all figured out how to build little web server farms, and everything for the business past that is just the normal business stuff, advertising, terms of service, that type of deal. So one of the things when we hear about these massive CapEx expenses for artificial intelligence is it can be very easy to think that AI is now mature. Like, even though you only started talking about it 3 years ago, it grew up fast. It was like this alien technology that grew up fast in 3 years. But anyway, so there's this idea like, oh, yes, this is how you build AI infrastructure, right? You buy an NVIDIA GPU and you put that into a $200,000 server, and then you use NVIDIA's networking, stack in order to connect everything together. This is how you do AI. But the important thing to realize is that's not true, right? Artificial intelligence is an incredibly immature technology stack, and we really don't know what this is going to look like in 2030, especially not in 2035, how it is all going to work out, right? GPUs right now, especially with NVIDIA, are incredibly expensive. What's interesting, if you hear of Grok, not Tesla's Grok, or not Musk's Grok, there's a different Grok out there. What's interesting with them is they've come up with these special inference processors, right? So all they do is inference. They cannot train models, but basically they're used to deploy models, to actually use models. They can actually build, apparently, a data center in something like 5 weeks. You tell them you want an AI data center built just for inference, just for actual processing purposes. They can build you that data center in something like 5 weeks, and it's incredibly inexpensive, compared to NVIDIA, because it's a task-specific processor that does the job it's supposed to do. And so one of the interesting things to be thinking about, like going into the future, is the whole question of what will the tech stack actually look like, especially the hardware, right? I think about this. I have a buddy of mine who posted something on LinkedIn yesterday, and apparently some pharma company out there actually created their own LLM just on medical stuff. Right? Again, not on Reddit, not on all this other stuff, right? They created this incredibly small, incredibly fast model that was only trained on medical information. Why? Because when they're processing things like medical claims and that kind of stuff, again, they don't want Reddit seeping in. They don't want like Twitter related hallucinations, right? They just want medical stuff. So they created this incredibly small, incredibly fast LLM that is exceedingly task specific. So one of the questions that needs to be asked, again, if you start looking at the load that's going to be on the servers that are running that and all that kind of thing, how they're actually deploying that, is do they need a $200,000 NVIDIA server to run this thing, right? If you can get, like, there's Dockling. So Dockling is a model from IBM for processing for documents. That's why it's called Dockling. Anyways, it's ridiculous. It's less than 500 megs. Like, the entire model is less than 500 megs. The thing is just blazing freaking fast. And so one of the things to think about, right, again, depending on your load and all that, do you really need to buy a $200,000 server and a $10 million rack? Or one of the things that I kind of wonder is, are we getting to a point with AI where a cluster of Raspberry Pi 5s might actually give you the optimum performance? Right? Because let's say you have 100 people. If you have 100 people hitting your site at any one time, let's say it takes 2 seconds or through however long in order to send a response back. If you create, so one Raspberry Pi, let's say, costs $50, right? 100 Raspberry Pis would cost $5,000. Now, with the engineering and everything involved, let's say it costs you $100,000. Again, that's a lot of money. So you go from $5,000 just for the Raspberry Pis, but you have the additional equipment, you put it into a colo facility, you have the engineering costs and the rest of it. Imagine if you spent, let's say, $100,000 to create a cluster of 100, or if you spent $100,000, maybe a cluster of 200 Raspberry Pis that are all dedicated to running incredibly small, incredibly efficient LLMs. Would you get far better performance out of that type of system than if you spent $40,000 for GPU, $200,000 just for one server alone, NVIDIA server alone, and you go from there? And I think that's the interesting thing. Again, with this whole argument between the United States and China, one of the things that I get concerned about is I think we are forcing China to look at different architectural styles, right? And in the real world of technology, it takes a lot of money for research and development. If you find a product that works, you don't keep spending billions of dollars to find something that works a little bit better. No, we found a product that works, that we can replicate, that we can scale, that we can sell the crap out of. We are going to do it. It doesn't mean that product is the best. It doesn't mean NVIDIA is the optimum way to do things. It is the way they figured out how to do it and basically stopped. So if you force other people to figure it out again, there's a good chance they're going to take all the lessons you learned, see what the results were, and come up with a better tech stack. That's just how this kind of stuff works. And so it's kind of interesting to be thinking about this, is again, that whole idea of what will the AI, especially the hardware stack, really look like as we start figuring out what to do with these products, right? There's this whole thing right now with artificial general intelligence, or supreme intelligence. I don't know what the hell they call this garbage, right? And there's just like this weird focus on it. Look, we need $1 trillion data center for superior intelligence, or whatever the hell it's called. Why? Again, if we're processing medical claims, I don't need an AI that can drive a car. If we're processing medical claims, I don't need an AI that can give me a sonnet in Shakespearean verse, right? I don't need an AI that will debate with me in Socratic Greek, right? I need an AI fucking process medical information. So it's like, I can get like a 500 meg LLM that will process medical information, or we can have this insane system that will do everything in the world. Like what doesn't make sense. So think about it like with a dishwasher, right? Dishwasher is a robot, right? Back in the days when we were trying to figure out what robots really were, the curious thing is a dishwasher is one of the few robots that every human had. We don't think about it, right? We think about Optimus with robots and maybe Tesla cars, but your dishwasher is in fact a robot. But here's the thing: do you want your dishwasher to know how to autonomously drive a car? No, Eli, that would be stupid. Do you want your dishwasher to be able to, again, say a sonnet to you about how when the sun hits your skin, it radiates the very life of existence itself? No, you want it to wash dishes. Again, as I say, that would be stupid on the face. Eli, why are you bringing up all of these stupid examples? They don't even make sense. Yes, that's my point, right? And what we see with a lot of these tasks that you put quote-unquote artificial intelligence onto, you need the equivalent of a dishwasher. You need the equivalent of a dishwasher, not whatever the hell it is they're trying to create. So this is interesting. Coming from Bloomberg, Google TPUs, so again, going back to the TPUs, tensor processing units, find sweet spot of AI demand a decade after chips debut. And this is the other interesting thing, again, with this hardware technology. If you look at NVIDIA, right? Don't you wish you would invested in NVIDIA in like 2018? In 2018, I think the price of NVIDIA stock was something like $10 a share. And people thought that was a little high back then. I don't know, $10 a share for a company that makes video game, cards? How much value can be in that, right? And now it's gone through the roof. That's one of the interesting things with a lot of this kind of hardware and stuff is until it gains traction, until quote unquote everybody knows this is what you have to build on, it kind of sputters along until it hits a point and then takes off. And I think that's going to be one of the things that happens with like these inference processors and other things, is I think we're going to start hitting that point where people just simply realize they don't need NVIDIA. And the other big thing that I think is going to come up is when they realize they don't actually need to do a lot of training. Right? Think about this. Training, because we talk about inference. So inference is what your users are going to be hammering the hell out of all the time, right? That is what actually answers the questions and makes the response based off of the request, based off of the model, right? That is what people hammer all the time. You train a model once, essentially. You train a model once, you deploy it, you see how it goes, maybe you do some retraining. Again, an interesting thing to be thinking about with NVIDIA is how much training needs to be done. Right? So you have all of these companies, all of these organizations right now that are doing all of this training. They're doing all of this investment. But at some point, the products are going to work well enough. At some point, they're going to get to be where they're like, you know what? This model works good enough. And then they're going to stop training. And that's a curious thing. Like when you think about the value of NVIDIA, if the value of NVIDIA is all about GPUs that can train, once you hit that saturation point of training, which we will hit at some point, then what happens to the NVIDIA stock? What happens to the value of NVIDIA? Anyways, in an AI chip industry that's almost entirely commanded by NVIDIA Corp, a Google chip first developed more than 10 years ago, especially for AI tasks, is finally gaining momentum outside of its home company as a way to train and run complex AI models. Anthropic PBC on Thursday unveiled a deal with Alphabet's Google to supply the artificial intelligence startup with more than a gigawatt of additional computing power, valued in tens of billions of dollars. The agreement gives Anthropic access to as many as 1 million of Google's tensor processing units, or TPUs. So that's one of the curious things here, right? We've heard this with NVIDIA and OpenAI. NVIDIA is investing in OpenAI, so an OpenAI can buy NVIDIA hardware, right? So that kind of keeps the idea that you need NVIDIA hardware. The interesting thing with Anthropic, again, this whole circular economy we've got going on right now, is Google has invested in Anthropic. So Google invests in Anthropic, and then Anthropic creates an agreement worth tens of billions of dollars with Google. But the curious thing here is not simply to use Google's data centers, that would be one thing, but it's actually to use Google's tensor processing units. Is this a way to then start boosting the TPU business for Google to possibly unseat NVIDIA? And it will be curious, like when you look at the value of NVIDIA just going into the stratosphere, what happens when NVIDIA starts to plateau, right? That's a problem in the technology world. Plateau is equal death. right? Again, it's all about investments. So going up is what you want to be, right? As soon as you plateau, basically the investors essentially think you're dead, and then everything starts going down. So curious thing to be thinking about with NVIDIA is as more companies go to non-GPU specific processors for artificial intelligence, what is that going to do to NVIDIA? And what will NVIDIA's next play be? Which will be curious. Google's deal with Anthropic is a, quote, really powerful validation of TPUs. I would feel better about it if Google hadn't invested in Anthropic so that Anthropic could then buy the TPUs. And that's one of the problems too we get with this whole trust thing. And I really want you to understand this because this is what Google does. Google comes out and says, look, this validates our tech stack because this $183 billion AI company is willing to spend tens of billions of dollars on our hardware. So obviously our hardware is valuable. It's like, yeah, but you gave them a lot of money so they could buy your hardware. It doesn't quite validate the same way. So that's where you have to take a lot of this stuff right now with a grain of salt. Is just, like, as I say, distrust, verify, stay suspicious. What you have to really understand with this artificial intelligence world is they are all in bed together. This is just an incestuous goat screw at this point in time. You do have to be very careful with what your interpretations are of what you read, right? What these people, they're not lying. They are not lying, to be clear. They just may be obfuscating a few points of fact that would redirect your opinion. Let's just put it that way. Let's see. Google's deal with Anthropic is a real powerful validation of TPUs, which could get more companies to try them, said Seaport analyst Jay Goldberg. Quote, a lot of people were already thinking about it, and a lot more people are probably thinking about it now. So again, if you hear this, NVIDIA is so expensive. What are other options? TPUs. Hey, look, Anthropic is now using Google's TPUs. Maybe we should use TPUs too. And again, in the tech world, that's where you start to get all the lemons, right? It's all about lemons. And basically, that's what quantum computing is about. Do you know why Trump really wants to invest in quantum computing? Because it's all about getting the lemmings to go in a vague direction. Okay, so we got billions of lemmings. We all have to get them to jump off of that cliff over there. If they jumped off that cliff over there, that's not good. We need them to jump off of that cliff. So how do we use quantum computers to get all the lemmings to go into that general direction? Let's see here. TPUs are a type of specialized product known as application-specific integrated ASICs, application-specific integrated circuits or microchips that were designed for a discrete purpose. So basically chips that were designed to do a very specific task. This is becoming a more interesting thing, especially in the hyperscale world. So general processing units were the big thing in the past, again, CPUs or even GPUs, right? These are processors, this is silicon that's supposed to do a lot of different tasks. Well, here's the thing. If it does a lot of different tasks, it will do a lot of different tasks pretty well. But it's not going to do any one thing great. One of the cool things with these ASICs chips is they design it to only do one thing. And until like 10 years ago, there really wasn't a market for it, because if you create a processor that literally only does one thing, then it can only do one thing, and then you can only sell it to whoever really needs that one specific thing. So that's why processors and GPUs, right? Because Intel makes a processor, AMD, ARM makes a processor, more or less everybody can use it. You can use it for a desktop, you can use it for a server, you can use it for a surveillance system, you can use it, right? But the thing is as these companies have grown, right? And again, we start talking about data centers that are the size of Manhattan. All of a sudden, a single company needing one specific processor, that may be hundreds of thousands or millions of units sold. Right? So instead of before Intel trying to sell 5 million units to the general public, Google can create a chip that only they are going to buy. We guarantee 5 million of these units being sold. They then become the market themselves. And I think this is going to be interesting when we start looking at this with architecture and design, systems design going over the next 10 years, as more and more processors, more and more hardware is designed to be incredibly task specific, and then clustered on a hyperscale. It'll be curious to see what that kind of stack looks like. Google began working on its first TPU TPU in 2013 and released it 2 years later. Initially, it was used to speed up the company's web search engine and boost efficiency. Google first began putting TPUs in its cloud platform in 2018, allowing customers to sign up for the computing services running on the same technology that had boosted the search engine. It was also adapted as an accelerator for AI and machine learning tasks in Google's own application. Because Google and its DeepMind unit develop cutting-edge AI models like Gemini, the company has been able to take lessons from the AI teams back to the chip's designer, while the ability to customize the chips has benefited the AI teams. Quote, when we built our first TPU system a little over 10 years ago, it was really about solving some internal scaling challenges we had, said Mark Lorimer, Google Cloud Vice President. Quote, then when we put that compute power into the hands of our researchers in DeepMind and others, that in many ways directly enabled the invention of the transformer, he said, referring to the pioneering Google proposed AI architecture that has become the foundation of today's models. So yeah, I think this is kind of interesting, seeing Anthropic buy 1 million TPUs with the money that Google gave them. What will this mean at the end of the day? Who the hell knows? But it is kind of curious, again, from that architecture standpoint. And the big thing that I really want you to take away from this is just the understanding that AI is not a mature technology. It's really important that you grasp that literally how we build our stacks 5 years from now are not going to look like how we build our stacks today. And so you need to be thinking about that for how you implement and deploy artificial intelligence into your systems. Does it make sense to buy a $200,000 server? Does it make sense to buy specific hardware? Is it better to use service-oriented architecture, basically rent services from other people? How should you build your software? All of that kind of stuff. It is one of those things to really consider. Remember, in the technology world, it is always a bet, right? Netscape was a great bet. Until Microsoft just killed it. Until Microsoft just killed it, right? Some things work out and some things don't. WINS. Anybody remember WINS? So there's DNS, domain name services. There was WINS, Windows Internet Name Services. So basically, Microsoft literally tried to create a proprietary DNS service, and thankfully, that crap failed, right? And that's the thing. It's all like so Microsoft killed a web browser. On the other hand, it couldn't kill DNS. Kind of curious how that works out. So this is the kind of bet and the things that you have to be thinking about and the things you need to be discussing with your executives. One of the things I noticed back when I was a consultant and I was dealing with executives and all that kind of thing is when you had small conversations with them over a large amount of time that they actually listen. If you try to sit down with the CEO and you try to do a brain dump on them for like an hour, it's not going to work out well. They're not going to remember any of it. Here's the thing. If every time you go to do a work order or every time you go for a project meeting or whatever else, if you just throw out the equivalent of a paragraph of what's currently going on in the technology world, it's amazing how much of that they actually pick up. So that a year from now, when you have to have the actual god-awful conversation about what the company's tech stack is going to look like, they will have remembered a lot of the things that you've said. And so when you then start arguing your point, they will be more on board with why you think it is what it is, right? It's important to understand with... One of the issues with like technology professionals, there's this idea that we feel like we quote unquote know everything. And so a lot of people want to push back on that because they're like, are you really as smart as you think you are? Probably not, to be frank. The curious thing is if you drop these little nuggets to your executives, if you drop these little nuggets to the employees, what it shows is that you're actually thinking about the problem. What it shows is that your thought process is evolving based off of the current environment. So basically, if a year ago you're like, okay, yeah, so, I'm thinking if we ever, just so you know, executive, if we're ever going to deploy, AI services, it's probably going to be about $200,000 for one of these NVIDIA servers. Right? And then like a month later, be like, oh yeah, I heard this Eli the computer guy, he was talking about these really small models. So I don't know, I'd still probably say, if we were going to do AI services, we probably would need one of those NVIDIA servers, but maybe not. And then the next month, you're like, oh yeah, there's this interesting thing with TPU. Have you heard of these TPUs? Yeah, there's these specific processors, right? And that's the thing, is you lead, right? You lead your executives down a story to where it becomes inevitable that they sign off on the project. Anything other than signing off on your recommendation, I mean, that just wouldn't make any sense. Right? That's what you're trying to guide your executives towards. So thank God I do education, so I don't have to do that right now, because artificial intelligence is just stupid. It's just stupid at this point in time. But this is one of those things you might want to think about. Again, with your company, if you're really looking for advice, I would say things like lunch and learn programs. Just like I do like Silicon Dojo, I go to Durham to teach these classes. One of the things you might want to be thinking about, right? If you were in a management position, or if you want to be in a management position, that's the thing, right? If you're in help desk right now, or whatever, a junior level, a developer, like ask your boss, hey, I would like to do every month or every couple of weeks, or maybe every week if they're up for it, I want to do a lunch and learn session. Everybody's interested in artificial intelligence. I'm going to create a half-an-hour presentation on the current state of artificial intelligence to keep everybody on board so that they understand what's going on. I don't suppose the company would be willing to buy, pizzas or sushi or whatever your company buys at this point in time to feed folks that show up. And it's like, wow, that shows your motivation. That shows that you're thinking about the problem, and within your realm of resources, you're trying to figure out a way to create solutions for the problem, right? If you're a junior level admin, you are not going to get a decision on the fucking stack. You're going to do what the fuck you're told to do, right? You're a junior level admin. That's how it should be, right? So you don't get to make decisions on the stack. If you're a junior level admin, you probably don't get to talk to the executives. And even if you do talk to the executives, they don't really want to hear what the hell you have to say, right? And so the thing is, look around in your environment. Again, that's the whole question. What can you actually do? What actions can you actually take? And doing things like lunch and learn sessions is something that almost any of you can do. Hey, can I spearhead this initiative? I'll do these, 30-minute presentations, once a week or once every couple of weeks to get everybody on board with artificial intelligence, right? And again, especially if you're a junior level admin, you're probably not making very much money compared to everybody else. So you quote unquote wasting some time creating up with these presentations is not the expense of the senior engineer, right? That's one of the things you have to think about too. Like with senior engineers and executives, they may see a need for something like lunch and learn sessions. Like, crap, we should really do some lunch and learn sessions. But if you're the executive, you're the senior, you're getting paid way too fucking much money to worry about coming up with a slide presentation to show folks at lunches, right? And so that's the thing. You have the junior come in. Oh, hey, look, that's a valuable thing. And that's how you can show value to the company and move things ahead. If you do get laid off in the future and they say, what do you do for the company? It's like, well, this is what I did, and I spearheaded this program. I think one of the interesting things that you should really be thinking about when you go to interviews in the future, if you can get them, is talk about what you spearheaded. Not simply what you did, right? What problem did you see? Did you come up with an actionable plan for, and then you went to your management and asked for the permission to go with that plan? The spearhead, not simply I did, but I saw, I planned, I implemented plan, right? So anyways, there you go. There's some advice. Do with it as you will. So, what are your thoughts with TPUs and all that? Put your thoughts down below. If you like these videos, give us a thumbs up. If you hate these videos, give us a thumbs down. Call me amazing, call me a dumbass. Just be a real nutnik and do it down there in the comment section. Do remember silicondojo.com is what I actually care about. Free to end user hands-on technology education that empowers you to do whatever the hell it is you want to do in Durham, North Carolina. We're having a class on AI and SQL coming up on November 5th. We're having an AI and web scraping class coming up on November 19th. Go to silicondojo.com to see what those are about. Do remember, free to the end user is not actually free. There's a donor box link down below if you want to throw some money in to support me with this project. And with that, see y'all later.